Hello, students. Welcome back. And I want to give you some information before beginning the laboratory activity on energy of reactions. If you recall from yesterday, we talked about exothermic and endothermic chemical reactions. And again, we're talking about the change in energy that takes place contrasted between these two descriptions. Endothermic, take heat energy in and it gets colder. Exothermic releases the heat energy and it gets hotter. So keep those two terms in mind as we prepare for our lab activity dealing with energy of reactions. Because today, if you notice in your observations section, you are going to be mixing two chemicals together with water. In the first beaker, in the first example, you are going to be combining something called calcium chloride with water, and you're going to be noting whether there is any change in temperature that takes place or not. In the second example, you're going to be combining something called ammonium nitrate and water, and again, observing whether there is a change in temperature that takes place. And you're going to be using that information to graph your data in order to determine, based on the graph, whether you are illustrating an exothermic or an endothermic reaction. So give me a couple moments to explain what I'd like you to do. Oh, isn't that pretty? That's not what I wanted to show you, though. I don't even know how that happened. But what I would like to show you is the next slide here. That was interesting. Okay, so energy of reactions graph. What you are going to be doing in your book on the graph is noticing the X and Y axis here. On the X axis, you're going to be labeling it time. Time is along the X axis. Along the Y axis, we've got the temperature. And you'll notice in your book, you've got lines there, and I'd like you to distribute your data in the following way. Along the X axis, you're going to label that from 0 to 120, which is the number of seconds in 2 minutes, because you're going to be making your observations over the course of a 2-minute period of time from beginning to end. Over on the y-axis, you're going to be labeling it, starting it at 10 degrees Celsius all the way up to 30 degrees Celsius. That'll be a better range of data for us in order to see the change in energy, as opposed to starting it at 0 at the bottom of your graph. The change may not be big enough for us to observe in a graphical sense. So start at 10, finish at 30 on the top of your graph. Now, once you complete your experiment and you make your observations, you're going to be plotting your data on the graph, comparing the time versus the temperature. And I'm not giving you the answer here with this picture, but rather I'm trying to help you understand how to interpret what the graph may show you, because there are a few different possible outcomes to the shape of your graph. It is possible that when you graph your data, you might have a diagonal line going up from left to right, like line A here. It's possible that you might have a line going diagonally down, like line B. Or you might have a graph that is completely flat, like line C. Now, earlier in the year, we spent some time interpreting graphs, and I just kind of want to refresh your memory as to how a scientist will interpret a graph in order to make a conclusion. So if you look at line C first, if you look at line C, can you tell me, is anything happening to the temperature from the beginning to the end of the experiment? from 0 to 120 seconds, is anything happening to the temperature? Or to put it another way, is there any change in heat energy? If you look at that flat line, your answer should be no, there is no change. So there is no change in energy illustrated by line C. It's unlikely that you will see that type of a line when dealing with chemical reactions and you're measuring the change in heat energy if your instrument is sensitive enough to measure it. What may be likely, however, is that you'll get a line that either goes up or a line that goes down from left to right on your graph. So look at this graph here for a moment, and can you tell me what kind of change in heat energy is taking place with line A? I'll make it multiple choice. Is there an increase or a decrease in the heat energy from the beginning to the end of this reaction? Hopefully, you said an increase because the line is getting higher. And the higher you are on the graph, the higher the temperature, an increase in temperature. Now, what about line B? Can you tell me anything about the change in heat energy illustrated by line B? Multiple choice. Is there an increase or a decrease in the heat energy of line B? Hopefully you responded a decrease in heat energy from the beginning to the end, because the lower on the graph, the lower the temperature, thus the heat energy. Now, here's where your interpretation skills will come into play with this particular experiment. After plotting your data and drawing your lines and labeling your lines appropriately, one of these lines represents an exothermic reaction, one of them represents an endothermic reaction. And my question to you is, well, which one is which? Line A. Is it an exothermic or an endothermic reaction? Is the heat energy going up or going down? Is it getting hotter or colder? As a result of this reaction, this line is in fact indicating an exothermic reaction. If the temperature goes up, it's an exothermic reaction. So by process of elimination and using your deductive reasoning, what would you say line B represents? An exothermic or an endothermic reaction? Yeah, hopefully you said an endothermic reaction. Why? Because it's getting colder. From left to right, the temperature is dropping. It's absorbing heat energy from the surrounding area. It's getting colder, like that ice pack. So this one is illustrating an endothermic reaction. Now, your challenge is this. I'd like you to watch the lab video, record your data, and then draw your graph, determine whether it is an exothermic or endothermic reaction, answer the questions, and write your conclusion. So go to it, ladies and gentlemen. We'll talk about it later. And until then, I'll say bye-bye.